Okay, so now since we have understood ionic ions and ionic bonding, let's look at covalent bonding. Okay, in covalent, so the difference between covalent bonding and ionic bonding is that covalent bonding occurs between two or more non-metals. So remember, ionic bonding occurs between a metal and a non-metal, whereas covalent bonding occurs between two or more non-metals. So covalent bonding happens when the outer shells of the electrons overlap to create a full outer shell on each of the atoms taking part. So let's take a look at um, car- uh, car- carbon and hydrogen. So I'm sure you would have seen this type of structure before, CH4. Now, another way to represent this is how covalent bonding works. So, we know that carbon has four electrons in its outermost shell. So, in covalent bonding, we usually show only the outer electrons. So, we've got carbon here showing its four electrons. And since hydrogen has one electron, it's going to share that one electron with carbon, and carbon is going to share its one electron with hydrogen. And the reason it shares only one is because hydrogen needs only one more electron to complete its outer shell. Remember, we said two electrons are needed to complete its first shell. So hydrogen shares its one electron, which I've indicated in blue. And because uh, carbon has these three electrons, it's going to attract three more hydrogens. And I'll draw hydrogen's electron in a minute. So they're going to overlap. Can we see that the orbits of the shells of hydrogen and carbon overlap each other? So this is how we would draw a dot and cross structure of covalent bonding. And because there is only one electron shared between hydrogen and carbon, we indicate that as a single bond. Say suppose there were two electrons like in CO2. So CO2 is we let's start by drawing the dot and cross structure. So chlorine, it's going to shift its electrons like this because oxygen needs two more electrons to complete its outer shell to gain eight electrons. So oxygen is going to share its two electrons with carbon, and it has its other electrons here. And on this side, it's going to attract another oxygen, and that oxygen is going to share its two electrons with carbon, and therefore carbon has four electrons, including the electrons which oxygen gave, and the oxygen has eight electrons altogether because um, it has the electrons from carbon as well as itself, so it adds up. So oxygen has eight electrons, carbon has eight electrons, and this oxygen has eight electrons. And because there are two electrons being shared in between them, it becomes a double bond. So O double bond C double bond O, or in other words, oxygen double bond carbon double bond oxygen. And this is how you would do a dot and cross structure for covalent bonds. Now that we know the type of bonding that occurs when each when each atom provides the other atom with electron, and in turn they get electrons from the other atom. There is another type of bonding which is called coordinative or dative bonding. Coordinate or dative bonding. Now, this bonding is just like is just like the regular covalent bonding, but the only difference is it both electrons come from one atom in the bond, and the other atom in the bond supplies the vacant orbital for the electron to use. So let me make this more clear. Suppose if we take a compound NH3, which is ammonia. Nitrogen has shared all its three electrons here, and it has two electrons extra. So, and hydrogen, which has no electrons, which has given that one electron it had, has a vacant orbital, has a vacant shell. So, what it can do, it can take these two electrons to complete its shell. So, therefore, this becomes like this, and we have that one hydrogen. So this is where, so nitrogen is the one who's providing the electrons, and hydrogen is the one who is providing the vacant orbital or the vacant shell for these two electrons to live. It's like renting a house. We rent Hydrogen is renting its house for two people or two couples, and so they can go and live in hydrogen's shell. As it's as simple as that. Now let's discuss the properties of covalent compounds. So small molecules containing strong bonds between the atoms inside the molecule, but only weak forces between the molecules. So the atoms have strong forces in between them, but the molecule itself has weak forces. The second property is that covalent compounds can be solid, for example, diamond and graphite. They can be liquid, like water, and they can also be gas, like iodine, which can vaporize. They are solids when if they are solids, they are molecular crystals such as iodine with low melting points and boiling points. This means that it has, because iodine has weak forces in between them, they can easily be broken, which lowers its melting and boiling point, and therefore they can turn into vapor quite easily. They are insoluble in water but are soluble in organic solvents such as ethanol. So remember, ionic compounds are soluble in water but not in organic compounds, whereas covalent compounds are insoluble in water, and they are soluble in organic solvents such as ethanol. And covalent compounds do not conduct electricity in solid or liquid solution form. So let us look deeper into some of the examples of covalent compounds. The first example we look at is diamond. So this is the structure of diamond. Now we know diamond is unbreakable. We know it's a really strong um, metal. Is a really strong non-metal. Sorry. And this is because it's made out of it's because of the covalent bond present between the carbon atoms. Can you see that each that each carbon is connected with another carbon, and therefore four it is formed out of four carbons, or in other words, it forms four covalent bonds. And because of this, it's called a giant covalent structure, and it is very rigid. It is a very hot solid with high melting and boiling points, because the covalent bonds are so strong that you need a lot of energy to break them down. And another property of diamond is that it does not conduct electricity, because all the electrons from each carbon is taken, and therefore there are no free electrons, and thus they cannot conduct any electricity. So this is of diamond. Another uh, giant covalent structure is graphite. Although graphite is not as strong as diamond, it is very brittle. And the difference is, graphite has forms only three covalent bonds. As they've shown here, it's 1, 2, and 3. It forms only three covalent bonds, and they exist in layers which allow them to slide over each other. And between the layers, they have these weak forces, and therefore it makes them very brittle. And each carbon has one free electron, and therefore it's able to conduct electricity, unlike diamond. And the last example we look at is iodine. Iodine is a molecular structure, and it's called a simple molecular structure. And in such simple molecular structures, they are held by strong covalent bonds. The electrons are held in pairs by strong covalent bonds. However, between the molecules are weak forces of interaction, resulting in iodine having low melting and boiling points. It takes very little energy to break these weak forces up, thus making iodine volatile and soft. Volatile meaning they can be made into vapor. They do not conduct electricity, as there are no ions or free electrons. There is another example of covalent structure, which is water, and we will discuss that in the next session.